In this video we're going to work on graphing logarithmic functions like log base 2 of x plus 3. Remember that logarithmic functions have a vertical asymptote. One of the first things that you need to do, and by the way you can't just type this in the calculator as is because you have a base 2, and on your calculator you have logarithms with a base 10 or e. One of the first things you want to do is figure out what the domain of the function is. And when you're taking the logarithm of a value, you can only take the logarithm of something that's positive. And you can play with the other log keys on your calculator. If you type in log of 1,000, you get 3. If you type in the log of 1,000th, 0.001, you get negative 3. But if you type in the log of 0 or a log of a negative number, you get an error message. So that means that this value connected with the logarithm always has to be positive. So that means that x plus 3 in this example has to be greater than 0 so that it's positive. It cannot equal 0 and it cannot be less than 0. Less than 0 would make it negative. Solve this, you get x is greater than negative 3. That's the domain of the function. You can only use x values that are greater than negative 3. The domain and the vertical asymptote and the graph, all this goes hand in hand. The vertical asymptote is actually the same number, it's just that x equals negative 3. Remember that an asymptote is a line that the graph approaches, doesn't touch. So where x equals negative 3, we're going to draw a vertical asymptote. So on my graph, where x is negative 3, first of all, I'm going to draw a dotted line here. That's my vertical asymptote. That's the line on the graph that the curve, when we graph it, the curve will approach this but not touch it. Now, my domain was that x was greater than negative 3. What that means in relation to my graph is that my curve is going to be over here on this side where my x values are greater than negative 3. I won't have anything graphed on this side of my asymptote. The next thing we want to do is look at this graph, look at this function, and remember one of the most important things is intercepts. The x-intercept of any graph or any function is always found by setting it equal to 0. If I take log base 2 of x plus 3 and I set it equal to 0, remember that these are two parts that stay connected with the logarithm. The only way to move these away from the logarithm is to change it to its exponential form. 2 to the 0 base exponent equals x plus 3. Remember also that anything to the 0 power is equal to 1, so 1 equals x plus 3. Subtract 3 from each side, and that shows me that it's going to touch the x-axis at negative 2. Now, so I'm going to touch my x-axis right here at negative 2. I know that. I know I've got this line. Now, your curves for functions are either, for logarithmic functions, are either increasing or decreasing. And whenever I look at this, a couple of things I want to consider. First of all is my base number. As long as the base number is greater than 1, and it is, I have a base number here of 2, greater than 1, and I don't have any negatives in here to make it decreasing. So what's going to happen is the curve is going to be increasing. I'm going to start down here by my asymptote and get very close to the asymptote. It's going to curve up, cross the x-axis at where x is negative 2, and continue to go. Now, this is a rough sketch of the graph. It curves up, it's increasing from left to right again because you have a base that's larger than 1 and you don't have any negatives in here to make it decrease. If you had a negative maybe in front of your logarithm, then it would make it decrease. You'd start up here at the top of your asymptote and curve down. Or if you had a base number that was something less than 1/2, that could also make it curve downward or make it a decreasing function. But the three main things that you want to find with these are your domain, which we did first by setting this greater than 0, the vertical asymptote, and I would put this on there first because it gives you a boundary for your curve, and then set it equal to 0 to find your x-intercept, graph it to see whether it's increasing or decreasing. Those are the main things you need to graph a logarithmic function, especially when you have a base that's not a 10 or e. Now, if you had an log with a base 10 or an ln with a base of e, you could just type those directly into your calculator.